Hey everybody, this is Alex Merced from alexmercedcoder.com, and it's been a while since I've done anything about testing, and I've done videos on testing with Jest before, but they're real basic, really introductory, so I figured, you know what, I'm going to go through the Jest documentation again and do some new videos on testing with Jest. So, with that, and we're going to do it over across multiple videos, okay, so we can try out a lot of the features here. So what I'm going to do is open up Visual Studio Code. I am going to open a folder for, we can just kind of do a new thing. I will create a folder called testing, and in that folder I'll create a folder called Jest, and this will be our workspace. Okay, I'm gonna move this to the side so that way I can have the Jest documentation over here to the side. Let me just take a little bit more space for VS Code. Okay, cool. Okay, so let's get started. So what I'm going to do is create a new Npm project. So terminal, a new Npm project. So npm init-y. And Jest, since Jest is not something, again, the difference between a dev dependency and a dependency is the dev dependency is something that's not needed for the program to run. It's something that you're probably using as like a tool for your development time. So are things like Nodamon, testing libraries, compilers, things that, again, they generally run processes not when the program's running, but outside of it, like CLI tools, TypeScript. These are what generally gets put under the category of dev dependency. So when I do npm install -- save dev, that's going to save this as a dev dependency. So when I say I want to install Jest, I take a look at my package.json. After it's done installing, it's going to take a second. Looks like Jest is a big old library. And then I will go down here and I see it's under dev dependencies. And the benefit of that is like when you use tools like, let's say Heroku or something like that, you know, they'll know which the dependencies are dev. So once everything is kind of set up, they'll know like these dependencies you don't need to kind of keep around and optimize space usage. Cool. Okay, so the bottom line is this. Generally, the way you do testing is you are making functions that do something. So I'm going to make a file. I'll just call it my functions.js. So this is where I'm going to write my just run-of-the-mill functions. Okay, so I'm going to write a function that adds two numbers. Const add nums equals xy. And this function should return x plus y. Okay, and then I will export this function. Okay, module.exports equals, no, we'll just put this in an object, add nums. Okay, so I've exported this function. I might be using this throughout my entire program. And the idea is that, like, you chop up your program, you're making it to small pieces that do a specific thing. And we want to test, is it doing that specific thing right? So that's why we run tests. Okay, so then what I'm going to do is you create a test file, which is always going to end up with the suffix test.js. So I'll create another file and we'll call this functions.test.js. Okay. And because of this, it's going to know that this file has tests for the contents of this file. So it's either going to have the same name, just one is called test. So I can just write a test. Okay, I still have to import the function, so const, and then I'm going to get the add nums equals require / functions.js. Okay, so I'm bringing in this test, and then we write a test. Okay, and this test function, what it's basically saying is that Control Z, test. What I'm saying is I'm going to run a test. Now the first argument is a label, like what do we want to show up in the terminal that shows which test it's running. So I'll just say testing add nums. Okay. So I'm going to test add nums. And then second, I pass in a callback where I'm going to specify my test. So this is going to be the test it runs when it runs this particular test. And essentially what it is Okay, I say expect, which means I expect a particular function. So expect takes an argument. What is the function that I'm going to run? So I want to try add nums, and I'm going to pass it some arguments. We'll say 1, 2. Okay, and what do I expect 1 plus 2 to be? 3, right? So then off of that, I'm going to change to be 3. Okay, so the idea is that if this function was created right, it should return 3. Okay, so now all I have to do is just run the test. And to do that, I think I should just have to type in test, finally run, and we have to make a script. I don't think we have to make a script, but we will do that. So I'm going to change this test script, then I'm going to just change it to the word Jest. Okay, and I think when you just do Jest by itself, it should just run all the tests that it finds. So it's going to look in your project and run all the tests. I think you could just write Jest and specify the test you want if you want to run a specific test, but we'll get to that. So in this case, I'll just do npm run test. Okay, and it's running, and see, I found one test. So see, testing, add nums, and I passed the test when it ran the function. Now let's see if I altered the function and said it returns x minus y. So 1 minus 2 is going to end up being -1. Let's see what it returns. npm run test. And see, I get a fail. The test failed. Okay, and see, it says, hey, I expected to get 3, and this gave me -1. Okay, so now the cool thing is I can look at this. I can see which test failed. So here's the thing. Functions across a big application are changing all the time. And you might be editing one thing somewhere, and you might be editing a function that some other function uses, and you don't realize that you just broke that other function. By running these tests, you're going to run, and you have good test coverage, and you test most of the functions in your application. You're going to catch things that you might have accidentally broken and fix them before you get too deep in the hole. That's like the point of testing. Okay, but you see I get this message, and I can keep making more and more tests for each function. Now here's the thing. This is why it's important to write good functions, meaning functions that don't refer to things outside of them. So notice, if I need something, in this case x and y, it gets passed as a parameter. I don't reach for variables or things that are outside of this function's scope. This way, the function becomes easily testable because I know how it performs. It's going to be based on two things: the things that were passed to the function as arguments, and the actual things that happen in the function. It's not. I don't have to worry about external factors. Okay, so keep that in mind. Okay, you want to make sure that you write sort of self-contained functions to make them very, very testable. Okie dokie. And then here you can kind of see how you can run like your own tests. Like if you want to run a specific test. So let's see here. You can run tests with a variety of foster users how to run just on files matching my tests using config.json. Let's see here if I tried that myself. Just functions. Does that do what I think it does? Nope, because I wrote it wrong. Just functions. Well, to do that, it wants me to install it globally, which makes sense. Generally, if you want to use like a command line tool, if you want to use the actual command, you have to install it globally. And if you want to use it locally, like we're doing here, you would then create a script. So if I wanted to, I could change the script and change it to like just functions. And try this again and see if that works. npm run test. And it found the test, okay? But now it's not going to run any other tests because I just specified which test I'm going to run. Cool. Okay. And then here's like bar configuration. I'm not going to get into that. Let's keep going on with some of the other functions. Let's go to the docs. And where are the table of contents? Is this right here? Yeah, there we go. Using matchers. Okay. And again, it doesn't expect, just takes in whatever expression you pass into it. So all you're saying is that I expect this expression to be whatever this is. It doesn't have to be a function. It could be a variable. You might be testing what certain variables are worth. Or whatever, you put the expression you want to evaluate here, and the result goes here. Okay, so let's show you an example of that. So let's say instead, I want to test that I have a variable called 5, and I want to test that it actually equals 5. I'll export 5. Let's go back to my functions.test and bring in 5. And then I'll write another test. So I'll just copy my first test. And we'll say testing 5. Okay, and I'm going to expect that 5 to be 5. I'm literally just saying, hey, I expect this variable to be 5. Okay, and let's see what I got. I got one failed. Which one? Test only 5. Why? Not a number. Why is 5? Oh, because I put it inside add nums. Oops. Oop. Oop. There we go. I expect 5 to be 5. So let's run that test again. And see both passed. So test suites represents like one test. So like this whole file here, functions.test.js, is one test suite. So I had one test suite and it passed. But in that test suite, I had 2 tests. Okay. And again, I can read through like the results, but everything went fine. So life is good. And again, you can do all sorts of cool stuff. I mean, that's really all testing is. You're just saying, hey, I expect this to be that. To be null only, and like here are some other functions you can use instead of just saying, hey, it has to be 5. I just want to care that this number, like this 5 variable, has like something of value. So in this case, we could use like to be null. Let's say, hey, like I expect this to be null. I expect it to be undefined. I expect it to be defined, meaning anything that's not undefined or null. To be truthy, something that evaluates as true, something that evaluates as false. So you can use those to evaluate things. Because sometimes when you're trying to evaluate, it's not necessarily a specific return value. You just want to make sure that it's giving you something. So I want it to be defined. I don't want to get undefined returned. So I can check that, or I can check, hey, is it a number? So here, or is it a specific number, like to be greater than this, to be less than that. So I'm saying, hey, I want the result to kind of always be this. Run the tests. And also I can write multiple tests for the same function. So like, let's say I go back and I write multiple rounds for, okay, for add nums. So we'll say 0 plus 0 should be 0. 3 plus 3 should be 6. And it's going to run through each of those. So then when I run this thing, let's see, I pass all the tests. But see, these aren't considered individual tests. They're all part of the same test. Okay? Now let's say I make one of them intentionally wrong. Like if I write the test poorly, so in this case, 3 plus 3 should be 6, but I accidentally wrote 5. Okay? Let's see what I get. I get an error. I failed one of the tests, and see it tells me I failed this specific round. And in that specific round, it expected 5, and it got received 6. And that's because I can look at that and be like, wait a second. 3 plus 3 should be 6, so my test is what's wrong. So let me fix my test. Well, that's kind of it. It's just basically you want to write any function you write, ideally, should have a test that tests that the function does what the function is supposed to do. And your function should be written in a way where you can easily just test them in isolation. That's essentially the bigger principle here. Like the testing, how you write the test itself isn't particularly scientific. It's just like, does the thing do this? And you write as many scenarios to try to catch any kind of possibility, etc. You know, and again, there's like all sorts of different functions you can use. That, like, you know, the thing should contain, or the string equals matches this string. So in this case, it's matching like a regex. Again, writing the test isn't the issue. And then here you can even test for errors. You can say, hey, I programmed my function to throw certain errors if you give it certain stuff, and you can test for those errors. So that's pretty cool. But the grander issue is knowing your function and writing your function in a way that is testable. So that means not referencing things outside of the function scope. And what do I mean by that? So in this case, in this function, let's say I define 5 before add nums. I don't do this. Return x plus 5. Okay? Because then what happens? If I export this function, but I don't import 5, okay, I'm going to run into sort of like, it still should be testable, but you start running into sort of things like, the test is not going to tell you necessarily that the function's wrong. It could be someone changed this variable here, and that's why the function's breaking. Like, the errors will still tell you if something's not working right, but it's going to be a lot harder to find the problem. So if I really wanted 5 to be passed in, I'd be better off labeling it y and expecting that someone passes 5 as y when they use the function. You really want the functions to be self-contained. But yeah, I mean, testing is pretty simple. You can see it's just literally just saying, I expect this expression to have this result, and if it is not this result, the test fails. If it is this result, then the test succeeds, and that's all it is. That's it. There's no, there's a bunch of different libraries for testing. So Jest is one, and this is specifically for JavaScript. Every other language has their own testing library. So Jasmine.js. So this is another one. Behavior-driven JavaScript. It's just like if this expects, and they all kind of look the same way. So you expect to be true. There's Mocha. And say you're saying the same things like exert if this is true. And see here, what you do is you create you describe a test, and you create like a chain of tests. There's Cypress. This one's kind of cool because it can test some things that you can't test in the other ones, like whether a button is in your HTML or something. That's kind of neat. I mean, you could test. I mean, that's where the art of testing comes in, where you're trying to test for certain like edge cases and thinking through which edge cases to test. Like thinking through like what are the scenarios that we wouldn't expect would break this thing, that could break this thing. But the actual writing of the test is pretty straightforward. It's the thinking through like, what are the bajillion ways I can break this function, and writing a test to catch all those specific ways so that whoever's writing the function plans for them. Cypress.io, other good libraries, and there's a few more. Mocha, Jest, Cypress, Jasmine. Let me just go to npmjs.com real quick. Testing. Mocha, Chai. Yep, Chai's another one. Karma's another one that you see a lot. Selenium's another one you hear about a lot. Yeah, I think that hits all the big ones for JavaScript. And then if we go to Python testing libraries, which generally should be doing the same thing. Okay, let's go here. Okay, so let's see here. For Python, we have Robot Framework. PyTest. Makes sense. Test project. These aren't the most unique names. PyUnit. Nose2. Behave. Lettuce. Testify. I'm sure they pretty much work the same way. Like I think we saw a code snippet right over here. So you can see here it kind of does the same things. Like I assert this. So first here, like this is the expression. And then we're asserting, like that's the expression. And if that's true, and again, you can even test, you don't even need a testing library to do tests. You can just test, like I can do this. I can actually just like create a new file. Totally forgot about the assert function. That's actually built into JavaScript. It's like a testing, literally that's what it's for. New file. Call it test.js. Let me just do this. Let's change this to node test.js. There we go. And then if I go to this test.js, I will bring in add nums from require / functions. And there's a function called Console.assert. Okay. And basically verifies whether the value is truthy. So basically I just put my deal here. I'll say, hey, does add nums 3 does it equal 6? That's what I want to assert. I want to assert that the result of that equals 6, and then we'll say here simple assertion test. If it is not, assertion error is thrown provided, and then I provide the error message not equal to 6. Okay, so let's change this like to 5. 3 plus 3 should not be 5. So it's going to throw an error. But if I do npm run test just with console.assert, see, I get assertion failed, not equal to 6. And if I say it is 6, I get no output because it all worked out. So theoretically, you could write tests with just straight JavaScript using console.assert. It doesn't offer you quite as robust a set of tools to do so. But you can still create a lot of tests that test that your code does what it's supposed to be doing. But yeah, that's the basic premise, at least conceptually, what you're doing with testing. It does get complicated when you're trying to like program larger like component-based things. Like if you want to use just to test like a React component, then you might be focusing on like testing specific values, like making sure that the state equals what it's supposed to equal, and things like that. But yeah, that's all it is. You're just testing your assumptions. You're asserting that this must be true, and if it is not, the test has failed. That's testing in all languages. Again, there's Ruby testing libraries. I'll do the one last Google search. Every language has got them. Okay, Cucumber, Capybara, they all got them. Okay. So my name is Alex Merced from alexmercedcoder.com. Originally I was going to see if I could split this into multiple videos, but as usual, when I cover testing, it turns out it's not the most complicated thing in the world. It's just thinking through what you want to test that is the challenge, not the actual doing of the testing. Okay, like what are the gotchas that I should test for? What are the things that the program or the function probably didn't think of that should be tested? Kind of like if you're making a calculator function, testing for like dividing by 0. Or what happens if I put in non-numbers into that addition function? That I control for that I actually throw errors to make sure? Like these are the things that quality testing considers, is like all the edge cases. And that's less about how do you write tests, more than sort of like the understanding of the test writer of what can go wrong, which is more of a function of your fundamental understanding of what the code is doing and how the language works. So your ability to write good tests is going to come down to your ability to understand the fundamental programming language. This is why you should always spend time understanding the fundamental programming language, reading the language's docs, revisiting those fundamental pieces. Because I know every time I go back and take a look at an array in JavaScript, or look at an object in JavaScript, or dictionaries in Python, I always learn something new. There's always some wrinkle that wasn't clear the last time when you read through all that stuff. But it's those things that are going to make those edge cases clearer. So my name is Alex Merced from alexmercedcoder.com. Have a great day and enjoy.